Let's talk about the basics of electrolysis for GCSE chemistry. So make sure you save this because you can apply this to a number of different examples. So first, to understand electrolysis, let's say what it is. Looking at the name electrolysis or electrolysis, lysis essentially means to split something up. And electro means, well, electricity, essentially. So we are splitting something up using electricity. As our general rule, we can say we are taking an ionic compound and we are splitting that up to give us back the individual elements, right? The neutral elements. Okay, now that does get a little bit more complicated when we get to aqueous electrolysis, but that is a story for another day. For now, let's stick with the basics. So to do that, we have this general setup here where we have our reaction vessel. So that could just be a beaker. And within that, we have got a liquid, and that is the liquid that is going to be electrolyzed. So we call this liquid our electrolyte. This Easter, we'll be running intense exam revision courses covering the entire A-level and GCSE curriculum. Best thing, it starts at only £20. Limited time offer, so click the link in my bio to sign up. And this electrolyte can either be a liquid ionic compound, so molten, or can be a solution of an ionic compound, so aqueous ionic compound. What we get, as I mentioned before, depending on these two conditions, we can talk about later, okay? But what we've got, as well as our electrolyte, we have these two electrodes. These electrodes, the positive one is called the anode, and the negative one is called the cathode. The way that lots of students like to remember it, and to be fair, is how I remember it as well, is even though electrolysis ideally shouldn't make you panic, you can still think of the word panic to help you out. So panic, where positive, anode, and then negative is cathode. Okay? And then, of course, we have got our power supply because we need electricity to split up our compound in electrolysis. So what now happens? Within our electrolyte, because we have our ionic compound, we know that when we have an ionic compound, let's just call it XY, solid, if we melt that solid, so turn it into the molten compound, so melt, then that will split up into the individual ions, liquid. And we also know that if we dissolve an ionic compound in water, then it also splits up into its individual ions, but this time instead of liquid, they are aqueous. So that means that within our electrolyte, we are going to have the individual ions for our ionic compound. So again, for now, let's just stick with liquid. We will have our X plus ions and we'll have our Y minus ions. Which electrode they are attracted to will depend on the charge, because we know that opposites attract. So our positive ion is going to be attracted to the negative electrode, the cathode, and our negative ion is going to be attracted to our positive electrode, the anode. Or in other words, cations go to the cathode, anions go to the anode. And when they go to their respective electrodes, we say that they are discharged. So they form their original element. So our X plus is going to form just X, okay? So we've gone from our ion to our element. That could be solid, liquid, or gas. It will typically be a solid because positive ions are usually metal ions. And then Y minus will form its element, which, because negative ions are usually non-metals, they would give us a diatomic molecule and they're forming their elements from their ions. Now, for more detail on how we actually get these individual half equations and detail of what's happening at each of these electrodes, we're going to need a part 2. Okay, so make sure that you are following, where we'll look more closely at what is going on here in terms of reduction and oxidation.